Yes, sir.
Okay, so good. So yesterday we are discussing about the conformational isomerism, na? Okay, so in this one, what is mean by the conform? Which compounds are they exhibit as a conformational isomerism, Aditi?
The one with single bond, no sigma bond.
Single bond. So the compounds which contain the carbon-carbon single bond they exhibit as a conformational isomerism. Okay, so why the alkanes only they exhibit as a conformational isomerism, Aditi?
So because it is easier to turn the
Very
carbon
good.
atoms if they
Okay,
have a single.
so due to the presence of the carbon-carbon single bond, we have a free rotation. So whenever you're going to rotate so one carbon means here we'll get us some different structures. All the different structures are we can call as a conformers, and the phenomenon is called as here conformational isomerism. Okay, so yesterday we had seen some structures and we had seen some stability order also. Okay, and if you see N-butane, either ethane or N-butane. So what is the stability order means here? Staggered form is more stable than skew or Gachi form. Skew or Gachi form is more stable than partially eclipsed, and partially eclipsed form is greater than so eclipsed formation. Okay, and based on that one, I had given one more example also. What is the another example I had given means here? Ethane 1 comma 2 dipole. Okay, what is another example I had given? Ethane 1 comma 2 dipole. Okay, so in ethane 1 comma 2 dipole, so which one is more stable? What is the stability order of conformational isomers in ethane 1 comma 2 dipole? That is the question yesterday. And I explained skew form is more stable, okay, while comparing the staggered formation. Why the skew form is more stable means due to the presence of intramolecular hydrogen bonding. So due to the presence of the intramolecular hydrogen bonding, skew form is more stable. So in this one, how we can write the stability order? Okay, stability order. Stability order. So what is the stability order of the ethane 1 comma 2 diol means here? One is skew is more stable than staggered. Okay, staggered form is more stable than partially eclipsed. Partially eclipsed, and partially eclipsed one is more stable than eclipsed formation. Eclipsed formation. Okay, so which one is the more stable means Q form is more stable. Why does Q form is more stable means due to the presence of intramolecular hydrogen bonding. Okay, so what is the hydrogen bond means? The hydrogen bond which is present within a molecule. Okay, the hydrogen bond which is present within a molecule is called as a intramolecular hydrogen bonding. And intermolecular hydrogen bonding means the hydrogen bond is present in between two different molecules is called as a intermolecular hydrogen bonding. Due to the presence of the intramolecular hydrogen bonding, it forms as a cyclic rings. Number of cyclic rings are increases, their stability also is going to be increases. That is a condition. Why it is more stable means due to intermolecular hydrogen bonding, it is more stable. Have you got the clarity, everyone? Okay. Sirisha,
Yes, sir.
Sri Veda, Samita is absent today. Sai Akshit. Right, ma'am. Now I'm going to give one more example. Okay, I'll give some example here. So what are the examples means here? Hypohalites, ma'am. Hypohalites. Hypohalite. Sir, which we can call as a hypohalite means, what is the structure of the hypohalite mean? CH2 bond OH bond CH2 bond F. Okay, so this we can call as a hypofluoride, ma'am. Okay, hypofluoride we can call as here. Fluoride we can call. And another example. What is another example means here? Hydroxyamines. Okay, amino alcohols. Because of priority order means alcohol, we can give the first priority. Na? That means CH2 bond OH bond CH2 bond NH2. CH2 bond NH2. Okay, so this one also. Now I had given two examples. In two examples, which one is more stable formation? Options are skew, staggered formation, partially eclipsed formation, eclipsed formation. Which one is more stable one?
For the first one, it is skew.
Very good, Aditi. First one is skew. Okay, and what about the second structure, Aditi?
Sir, I guess it is either staggered or skew.
Which one?
Staggered?
No, Aditi. So in both the cases, let us see in this one and this one also. What is the name of this one? What is the IUPAC name of this one here? Okay, 2 amino, 2 amino ethanol. Okay, 2 amino ethanol. So this is the IUPAC name of this one here. Okay, so this we can call as a 2 fluoro. IUPAC name is called as a 2
fluoroethanol.
2 fluoroethanol. 2 fluoroethanol. Sir, both the cases, what is the stable formation means? In both the cases, Q form is more stable. Sir, how you are telling that both the cases Q form is more stable while comparing with the staggered one means here because of now I told that intramolecular hydrogen bonding due to the presence of intramolecular hydrogen bonding. Okay, so hypohalides are they exist as intramolecular hydrogen bonding. Okay, that means in between the fluorine and hydrogen, they have a hydrogen bond here. And in this one also hydrogen and nitrogen. Yesterday only I told that. What is mean by the hydrogen bond means the electrostatic attraction forces present in between highly electronegative atom and partially hydrogen is called as a hydrogen bond. Sir, what are the electronegative atoms we are considering in the hydrogen bond means we are considering only fluorine, oxygen, nitrogen. Other than this, we are not considering anything. Now you got the clarity, all of you? So which one is the more stable form in these two also means here skew form is more stable. Clear? And let us see, sir. Sir, why not staggered one is? Okay. And so staggered one is more stable means because of intramolecular hydrogen bonding. D. Okay. And sir, same concept. Okay. We can apply for other molecules also. Can I give one more example? One more example to make it clear, man. To make you clear. Okay. If I write CH2 bond CH2 bond Cl and CH3 is there. Okay, chloropropane we can call. Chloropropane we can call. In chloropropane, which one is the more stable formation? In chloropropane, which one is more stable conformer? Options are four only. We don't have any other options. Options are four only. Because of we are getting as only eclipsed form, skew or the partially eclipsed form, skew or Gachi form, and staggered form only. Okay, which conformer is more stable in chloropropane? Which one is the more stable? Which one is the least stable one? The two are the questions. My question is in the given compound, which one is more stable and which one is least stable one?
So the most stable is skew and the least stable is eclipse.
Aditi, for that reason only I had given this question. You are not observing the condition. Condition what I told here, you are telling that skew. When skew it becomes as a more stable whenever it is having hydrogen bond. Hydrogen bond is nothing but the electrostatic attraction forces present in between hydrogen and fluorine. Okay, and what are the electronegative atoms we are taking means nitrogen and oxygen and fluorine. In that three only it forms as a hydrogen bonding. But in the given structure, these three atoms are there. Aditi, as per you.
It's staggered and eclipse.
Very good, ma. Now you got the clarity.
So we haven't learned about the hydrogen bonding yet. They are gonna teach it this upcoming week.
Okay, then I'll teach upcoming week. Yeah. Okay. So here, no, which one is the more stable one? Means yes, staggered one is the more stable. Okay, staggered one. And least stable one is
Eclipse.
eclipsed one is called as least stable. Okay, so now you got the clarity, everyone. Okay, so all of you, is that clear?
Yes, sir.
Okay, right, ma'am. What happened? Sri Veda, Samhita, they are not responding. I think so. Okay,
Yes,
right.
sir.
So now let's see, ma'am. Here, same concept we can represent, we can explain based on the graphically also. Okay, so by the graphical representation also we can take here. Okay, so here, sir, how we can explain the graphical representation means here, for example, okay, so we are taking potential energy. Now I'll scroll up a little bit up. Okay, now here I'm taking as a potential energy on y-axis. Potential energy I'm taking on the y-axis, and dihedral angle I'm taking on the x-axis. Okay, so I'm taking as a dihedral angle. Okay, dihedral angle. So this one on y-axis we are taking as a potential energy. I think so already you know what is mean by the potential energy, and you may get the doubt what is mean by the dihedral angle. Okay, sir, what is mean by the dihedral angle means here, whatever the angle we are rotating. Okay, now let us see. So what is the dihedral angle? Angle of the eclipsed formation means we can take as a 0. So 0 and 360 degrees of the eclipsed formation. So because of eclipsed formation can be exist at 0 degrees and 360 degrees only. Na? Now you can check it out here in this structure. Okay, so eclipse formation is obtained at 0 degrees and 360 degrees. And let us see skew form. When skew form is obtained by the 60 degrees rotation, okay, and if you rotate the 300 degrees angle means then only you will get as a skew or Gucci form. So whatever you are rotating the carbon that we can call as a dihedral angle. Now you got the clarity? Okay, sir, here only one more word also it is there for us. Torsional strain. Okay, so what is the another word we are using means here? Torsional strain. Okay, sir, what is mean by the torsional strain means here? Sir, the repulsion between two atoms. Okay, what are the repulsions are there? In between two atoms is called as a torsional strain. Sir, when the having the repulsions means here, when two identical atoms are they comes close together. So because of now you are telling that. So when dimethyl, so one methyl here also methyl group is there, here also methyl group is there. So if you keep like this means here, if it is present one upon one, identical atoms are they having repulsion, they are unstable. To becoming as a stable, what they are doing, they are rotating with some angle. When they rotate with some angle, then only they becoming as a stable. In that also, which one is more stable means staggered one is more stable. So what is mean with the torsional strain, ma? Okay, so what is mean by the torsional strain means the difference, the repulsive forces in between two identical atoms is called as a torsional strain. Okay, now let us see. So this one also we are going to be explaining. So this one also we are going to be explained based on graphs. Okay, so how we can explain as a based on graphs means here in this one. Okay, so we're taking as a potential energy and dihedral angles. So what are the dihedral angles we are taking here? What are the dihedral angles we had taken? So we had taken dihedral angle is 0 degrees. Okay, we had taken dihedral angle is here 0 degrees and 60 degrees. Okay, 60 degrees also we had taken, and How much here? 120 degrees. Okay. And what is another one we had taken, ma? 120 degrees. First, I'll write bond angles here clearly. Okay. First, I'll take this. So, we are taking as 0 degrees. Okay. We are taking as a 0 degrees. And we are taking as a 60 degrees. And 120 degrees. 180 degrees. 240 degrees. 300 degrees. And last one is 360 degrees. 360 degrees. Okay. So sometimes they'll give the graph and based on that one they'll ask the questions in JEE level. Okay. So which is more stable according to graphical representation? Which is more stable? Okay. So which one is the more stable means the structure which is having the low potential energy. Actually, which one is the more stable? We are telling that. Which one is the more stable one? Generally, normally, if this hydrogen bond is not there means, so actually which one we can take as a more stable one? In N-butane. Now we'll discuss about the N-butane. N-butane. In N-butane, which one is the more stable? Eclipse form, staggered form, skew or Gachi form, partially eclipsed bond. Now only we have seen the diagram also. Which one is the more stable one? Sir, in N-butane, staggered one, anti-staggered one is the more stable. Okay, so which one is the more stable, ma? Anti-staggered. Okay, anti-staggered one is the more stable. Sir, where it is existing the anti-staggered means anti-staggered structure is exists as a 180 degrees angle. Okay, after that, which one is the more stable? Skew or Gachi form only, na? Skew and Gachi form are exist at which angle, ma? So skew also it is exhibit as a 60 degrees angle. Skew it is exhibit as here 60 degrees. At the same time, skew form is exist as a 300 degrees angle also. Okay, by rotating 300 degrees also skew form is going to be exist. Here, next, after the skew form, which one is the more stable? Partially eclipsed one. So partially eclipsed form is obtained by existing or by rotating of the 120 degrees. Okay, so partially eclipsed one. Partially eclipse. Okay, partially eclipse 120 degrees. Okay, and 240 degrees. Here I am writing as a P. I don't have much more space, so that I am writing as a P or P eclipse. Eclipse I write. Okay, so by 240 also it is exist as a partially eclipsed form. And when you are getting as a eclipsed formation means eclipsed form is obtained at 0 degrees centigrade, 0 degrees eclipse, and so eclipse form also it is exist at 360. Eclipse form also it is exist at 360. So in place of whatever the names I wrote names now in this one. Sometimes they write as they'll give as a diagrams. They'll give as a diagrams and they'll ask which one is the more stable. Okay, so which one is the more stable? And how much energy difference is there? What is the stability? Okay, torsional energy we can call it. What is the torsional energy means here? The energy difference between the eclipsed form and anti-staggered form is called as a torsional energy. Okay, you can call it as a torsional one. TIONAL, torsional energy. So what is meant by the torsional energy means? It is the energy difference. It is the energy difference between eclipsed form, eclipse, and minus of anti-staggered. Okay, sir, generally how much energy you will get as means here? So 12 kilocalories per mole amount of energy difference you'll get. Okay, so what is energy difference? We'll get torsional energy means here in N-butane, generally. So generally how much energy difference we can observe means here 12 kilocalories per mole amount of energy difference we can observe in this one. So now you got the clarity. Okay, so this is about completely conformational isomerism. Okay, all of you got the clarity. So how they'll ask the questions and at all. Okay, and Sunday you have a test nama. In Sunday test, I'm giving the optical isomerism and conformational isomerism. Structural isomerism already you wrote. For the Sunday test, I'll give here optical isomerism and conformational isomerism. Based on this one, I'll give the questions. Is that clear, everyone?
Yes, sir.
Okay, ma'am. If it is clear means until here we completed the isomerism concepts. Then we are going for attacking reagent. So what is the next concept we will go means here? So we'll go for the attacking reagents. Okay. Attacking reagents here. Okay. So how many types of the attacking reagents we are having means here? We have two types of the attacking reagents.
Electrophilic and nucleophilic.
Very good, ma'am. So we can call as a reagents. Simply we can call as a reagent. So how many types of the attacking reagents we are having means we have two types of the attacking reagents. It is very simple topic only, but it is easy. If you understand means it is easy only. Okay. So how many types are there? One is two types. One is electrophilic
And nucleophilic.
Electrophilic, and that's electrophiles we can call. What we can call means here electrophiles and nucleophiles. Okay, electrophiles and nucleophiles. Nucleophiles. Okay, in this one, first one, what is with the electrophile, ma'am? Think so many times.
Reagent.
Very good, ma'am. So which we can call as a electrophiles means here electron loving atoms or molecules or electron loving reagents we can call as a electrophiles. Okay, so here electron file means feeling we can call. Electro means here electron. Okay, and file, electrophile means here loving. Electron loving molecules or electron loving atoms are we can call as a electrophiles. Okay, here if they attract the electrons, the atoms or molecules are they attract the electrons means okay they have a positive charge or negative charge, ma?
Positive.
Very good, sir. Okay, so that means according to that one, positively charged ions are called as electrophiles also, na? Positively charged ions are called electrophiles. Are called electrophiles. Okay, so if they're having the positive charge, if they're having positive charge, means that electron deficient also, na?
Yes, sir.
Okay, so here whenever they're having the positive, actually when they'll get as a positive charge by losing of the electrons. If they loses the electron, means that electron deficient only, na? So electron deficient molecules are also called as electrophiles only, na? Okay, now you got the clarity, all of you. Electron deficient. Okay, electron deficient molecules are we can call as electrophiles. Okay, so now you got the clarity, sir. So which we can call as electrophiles means electron loving atoms or molecules are called as electrophiles. Okay, so if they are attracting the electrons, actually electrons are having negative charge. If they are attracting the electrons, means the atoms or molecules are having positive charge. So that's why positively charged ions also called as electrophiles. Okay, and electron deficient, if they are getting as a positive charging by using of the electrons only, they'll get as a positive charge. So positively charged ion, so that means electron deficient molecules also we can call as a electrophile. So we have two types of the electrophiles. What are the two types of the electrophiles means here? One is positively charged electrophiles. Positively charged electrophiles. Sir, what are the examples of the positively charged electrophiles? Any one of you? Sir, NH4 plus is we can call as an electrophile. CH3 plus also we can call as an electrophile. And
NO2.
CCl2 also, sorry, this is the neutral one here. This is a neutral electrophile charged species. H3O plus also we can call as the electrophile.
Sir, NO2.
Very good one. H3O plus also we can call as electrophile. NO2 plus also we can call as electrophile. NO plus also we can call as electrophile. Cl plus also we can call as electrophile. Br minus also we can call as electrophile. Okay, and I minus also we can call as electrophiles. Okay, so all these are the examples of even H plus. H plus I'm writing as a minus here. H plus also it is an electrophile. So all these are the examples of electrophile. And another example, another one. So what is the another classification means here? Sir, neutral electrophiles also it is there. Neutral electrophiles. Neutral electrophiles. Okay, so neutral electrophiles also we are having. Sir, what is meant by the neutral electrophiles? Okay, already you told that. Electron deficient it has to be there. All of you read 13th group elements, ma? 13th group elements. The halides of the 13th group elements. The halides of the 13th group elements are they act as a electron deficient molecules. So what are the examples means here? BCl3, BBr3, BI3, AlCl3, FeCl2, SnCl2. Okay, so all these are we can call as a neutral electrophile. Sir, why we are calling as a neutral electrophiles means they are the electron deficient. Ma? All these are the electron deficient. Now you can check it out here. BCl3, BBr3, BI3 means here around the boron we have a 6-state configuration. Sir, what is the 6-state configuration means? Around the boron we have only 3 chlorine atoms. That means this is the 1 chlorine, this is the 1 chlorine, this is the 1 chlorine. In the formation of 1 bond, 2 electrons are required. In the formation of 1 bond, how many electrons are required? 2 electrons. So boron is surrounded by the 6 electrons only. To attain the stability, how many electrons are required? To attain the stability, how many electrons are required? Sri Veda? Samhita? Sirisha?
So for boron, you need 3 electrons, sir.
No. Come again. I didn't hear you.
So for boron, it needs 3 electrons to get stable.
Right, that is only how many electrons are required to attain the stability?
5, I think.
5.
So the 3 electrons are required, sir.
No, ma. Octet configuration. Did you remember all of you? Octet configuration. What is the octet configuration means? The outermost orbital, if the element is having 8 electrons, means that we can call as an octet configuration. So the atom or more, the atom which contains the 8 electrons in the outermost orbital, then only it becomes as a stable. Okay. Now boron is having the 6 electrons. Total boron is surrounded by the 6 electrons. To attain the octet, octa means 8. So how many electrons are required?
2 electrons.
2 electrons. Okay. So they have a vacancy p orbital. Due to the presence of the vacancy orbitals, I write that reason, man. So why they act as a neutral electrophiles means here, due to the presence of vacancy orbitals. They act as the neutral electrophiles. Okay, sir. At the same time, here all neutral electrophiles also we can call as a Lewis acid. What is meant by the Lewis acids? Which we can call as a Lewis acid, Sirisha. Sirisha, what is the Lewis acid?
Sir, is it electron pair accepting
Very good. Electron pair acceptors are called as a electro, that is Lewis acid. Electron pair acceptors are called as a Lewis acid. So neutral electrophiles also we can call as a Lewis acid. So now you've got the clarity, all of you until here.
Yes, sir.
Everyone. Okay. So based on this one also, Sunday's exam I'm giving the some questions. Okay. So can I give some 20 questions? I told only 10 questions only. Okay. Anyway, no problem. I'll give 10 questions only. Okay. And I'm going to forward some assignment to you. Right, ma? Based on this one. Later I'll forward. Next. So what is the second one means here? Nucleophiles. Nucleophile. Okay. So which we can call as a nucleophiles? Nucleoma. So nucleo is nothing but here nucleus. Okay, so nucleus. And philic. Philic is nothing but loving. So nucleus loving atoms or molecules are called as a nucleophiles. Okay, actually nucleus is having which charge?
Minus charge.
Amma. Nucleus ma Veda.
Neutral.
It's a plus. Nucleus is having positive charge because of every atom it has a nucleus. Every atom it has a nucleus. Nucleus is containing the protons and neutrons. Okay, which are the subatomic particles present in the nucleus means here protons and neutrons. Protons are having positive charge. Neutrons are having chargeless mass. There is no charge for the neutrons. And electrons are revolving around the nucleus in a circular path. Okay, so the nucleus is having the positive charge. If atoms or molecules are attracting the nucleus means atoms or molecules are having negative charge now. The atoms or molecules are having negative charge. So negatively charged ions are called as a nucleophiles. Now you got the clarity, which we can call as a nucleophiles means negatively charged ions are called as a nucleophiles. Nucleophiles are classified into two types. Okay, at the same time, electron rich Electron rich molecules also we can call as a nucleophiles. Again, nucleophiles are classified into two types. What are the nucleophiles means? One is negatively charged nucleophiles. Negatively charged nucleophiles. Negatively charged nucleophiles. Sir, what are the examples of the negatively charged nucleophiles means here? F minus, Cl minus, Br minus, I minus, okay, F minus, Cl minus, Br minus, I minus, okay, and OH minus, COO minus, okay, and SH minus, OCH3 minus. All these are the examples of negatively charged nucleophiles. And NO3 minus also we can write now. NO3 minus also it acts as a nucleophile. Okay. And sir, neutral nucleophiles. Neutral nucleophiles. Neutral nucleophiles. Sir, what are the examples of the neutral nucleophiles? What are the examples? Sir, example says primary amine. All of you, what is the structure of the primary amine? RNH2. Sir, how it acts as an amine means on nitrogen atom it has a lone pair of electron. Due to the presence of the lone pair of electron, they act as electron rich molecules and they have a tendency to donate the lone pair of electrons. Okay, electron donors also we can call as what we can call ma? Electron donors. Any one of them? Sirisha. Electron donors are called as
So Lewis bases.
very good Aditi. Lewis bases. Okay, electron donors are we can call as a Lewis bases, or Lewis bases also we can consider it as a nucleophiles, neutral nucleophiles. Which nucleophiles means here? Neutral nucleophiles. Sir, what are the examples of the nucleophiles? Means RNH2. This we can call as a primary amine. Okay, if the amine functional group is attaches with the one alkyl group, in that we can call as a primary amine. R2NH. If amine nitrogen atom is attaches with the two alkyl group, is that we can call as a secondary amine.
So,
Okay.
primary, I mean, it's neutral nucleophile, right?
Yes, ma'am. All these are the neutral nucleophiles only. Primary amine, secondary amine, even ammonia also. Tertiary amine also. R3N.
Yes, sir,
Sir, how,
even H2.
R3N also it is a neutral nucleophile. Sir, how you are telling that means because of they have one lone pair of electron. And water molecule also it acts as a nucleophile. H2O. Sir, how the water molecule acts as a neutral nucleophile means on oxygen atom we have a two lone pair of electrons. It has a tendency to donate the lone pair of electrons to form the coordination covalent bond. Okay, and alcohols R bond OH. Here on oxygen atom we have a two lone pair of electrons. That's why alcohols also they act as a neutral nucleophiles. Okay, and thioalcohols R bond SH. And sulfur atom also it is having the two lone pair of electrons.
So, ethers.
Ethers, very good, ma'am. R bond, O bond, R. Ethers also they act as a nucleophiles here. Okay, clear? So all of you clear here? Everyone. And
Yes, sir.
C double bond O NH2 ma'am. Amide functional group. Nitrogen atom. So nitrogen also it is also act as here neutral nucleophile. So all these are the examples. Okay, and Sunday we have a test until here. Okay, so attacking reagents also it is that optical isomerism, okay, and conformational isomerism, and attacking reagents also you have a test based on this. Now all of you until here you understood? Everyone?
Yes, sir.
Very good, Veda. Okay, so thank you all. We'll continue in the next class. And one more thing. So up 3 days until Wednesday, I won't be available. I'm going my hometown. So due to I have some puja and all, so I won't be available. Just in the 3 days, just go through full GOC what we studied. Okay, just to revise. All these are the basic concepts. If you won't read all these, revise all these one means upcoming chapters are very difficult to. Okay.
Yes, sir.
Okay, ma. Done.
Yes, sir.
So thank you all. See you in the next class.
Thank you, sir.
Well,
Thank you, sir.
thank you, Aditi.